Let's start with an example quadratic equation. X squared plus 6x minus 7 is equal to 0. A mathematician named Al-Khwarizmi thought of completing the square, which means to make one part of the quadratic equation a perfect square for easy graphing and vertex finding. So he moved the negative 7 to the other side to get the two variables to add to equal 7. He made two quadrilaterals respectively, which areas equaled the two variables x squared and 6x. Now what he wanted to do was to make these two squares add together to make another square. So he split the quadrilateral of 6x into two rectangles, which dimensions 3 times x. Now, taking the original x squared square, he added these two pieces of areas 3x onto each side, and he found that there was actually a missing part of the square, so it couldn't form a perfect square. Now this square, once analyzing the graph, actually equals 9. So what he did was, when you add these two squares together, you add a certain amount to the two quadrilaterals to make it a full square. And algebraically, what this actually shows is that that amount is b over 2 squared, as I'm proving algebraically to the side. And this is where we get our formula for deriving the perfect square. Now the way we apply this missing piece of 9 area into our equation is by adding 9 to x squared plus 6s equals 7 to both sides. When we do this, we then have a perfect square on one side, x squared plus 6x plus 9, which we can factorize to be x plus 3 times x plus 3 equals 16, which is x plus 3 squared minus 16 after we move the 16 to the other side equals 0, and that is completing the square.